Welcome to part one's tutorial of the side-by-side bar chart. I have a completed sketch here for us. I want to use this as an overview to see where you're headed as your target. You'll notice we have two different charts, one referring to a left-hand digit, one referring to a right-hand digit. In the big picture, what this is referring to is simply that we have Idaho's towns and cities and their populations chosen as our little case study. We've asked Excel to strip out the left-hand digit and the right-hand digit from each of those numbers using a left function right there and a right one, very handily done. We've also got some population statistics, some descriptive statistics we call them. The N refers to the sample size. We have exactly 200 towns and cities in the state of Idaho. Average population, a min and a max. Boise, the capital, and Warm River City, the smallest town in Idaho, which is just to the north of Rexburg, about 45 minutes away. A lot of good information there. But more importantly, we have something peculiar happening that may be of interest to some of you. The left-hand digit appears to have a different distribution, dramatically different than the right hand. And there's a reason for this. It's a phenomenon that's sometimes called Benford's Law or the first digit phenomenon. So I'm going to take you to Wikipedia. And if you have an interest, you could do a Google search and get a wealth of information on this. It's named after Benford from the 1930s, an engineer, but actually discovered by Simon Newcomb, an astronomer back in the 1880s. And it's basically discussing the frequency distribution of digits. Sounds kind of dry for a topic, but you'd be surprised at all the different applications and some interesting things. On the left-hand side, it's appearing that the digit 1 actually occurs a lot more frequently than we would expect, 30% of the time roughly, and then digit 2 less so, and so on in the right-skewed manner. And then there are examples of applications such as fraud detection and election data and you name it. Some very interesting things. So we're going to stay focused, however, not so much on Benford's Law, but simply on the role that the side-by-side bar chart can play when looking at different kinds of issues, statistically speaking. It's a great way to compare different variables. You'll see it in the media, you'll see it in research all the time, a side-by-side comparison of data. All right, so let's get started in the actual template, and I'm going to choose to go right here so that it matches what you have. I'm going to inch that up just a little bit. Okay, so to get going in a proper way, I'd like to take you right down here to the right-hand digit box. What we're missing, we have pulled out the formulas so that we can teach a simple concept. It's a function that you would be surprised how often it can come in handy. It's called COUNTIF. COUNTIF works extremely well and in a very common sense way. It just needs two things. It needs to know what range of numbers are you talking about. Well, since I'm going to analyze the right digit first, I'm going to simply click and drag over all of the right-hand digits of Idaho's towns and cities populations. I'm going to stop when I get down to Worley City. Alright, so that's 200 towns and cities that I've highlighted there in terms of the right digits of their populations. But because I want to keep recycling, using this again and again for digits 0 through 9, I need to highlight those carefully or put the cursor maybe in the middle and do an absolute cell reference. It's just Command T on a Macintosh or F4 on the Windows-based operating systems. And you've done that before in previous projects, so that shouldn't be new to you. It locks it in so it doesn't shift on us. Then I do a comma right after that and a criteria. What the criteria is all about is it's just saying what are you trying to search for? What are you trying to count? I'm trying to count the digit 0, but I don't want to type 0 in. I'd like to click on the 0, which is cell H38 in your template. And when I hit return, it literally went through column E right there, and it found that there were 21 zeros. That fast. Pretty amazing. But the beauty of having clicked on H38, the beauty of that is we can now click and clone it. I'm going to get the black crosshair, and I'm going to send it down with a click and drag so that it totals up and it's behaving properly. I can spot check it. I can double click, say, the digit 5, and you'll notice that it didn't shift on me. It stayed in locked position. More importantly, you'll notice that the sum formula that I built in for you has everything ready to go, and it kicks out 200 for the total number of towns and cities in Idaho. The uniform theory is pretty simple. It's just taking 10% of the sum total of 200 right there. Well, that's 20. Why 20? Because if the right-hand digit didn't have any phenomenon at all, it just shows up in a random way, we'd expect no one digit from 0 to 9, no given digit would have any bias, then we would expect on average each digit to appear roughly 20 times. But that's theory, and then there's reality. The reality in the actual count shows us that we have some variability here. So that's exactly what we want to take a picture of. So we're going to click and drag over the counts and the theory for digits 0 through 9. I'm going to do a chart, a ribbon up here, like I would do on a PC or a Mac. Either way, I'm going to hunt down a column chart. I think I'll go with that one right there. That should do the trick. Okay, and I'll get it kind of sized up just a little bit bigger so we can appreciate it. And what I'd like to do next is get it so it makes sense. Right now it's not making sense in that the digits are saying 1 through 10 when in reality they should be saying 0 through 9. The other thing that I don't like about it is Series 1 and Series 2 are too generic. So when that happens, I typically click into the plot and I do a right click somewhere within the plot and ask for select data. And select data is going to be really crucial here. Now, what we're going to do first is we're going to notice that the Series 1 is in blue. That's referring to the actual count, and that's the one that has all that variability in it. So I'm going to just hand type, if you don't mind, the word actual count, and then I'll click on Series 2 and hand type uniform theory. Okay, so far so good. And then the other crucial issue is the x-axis isn't labeled properly. So I'm going to click on this icon and I'm going to drag down on top of digits 0 through 9. So that's what this is all about. It's waiting for me to declare where the range is. And there it is, 0 through 9. It informs Excel right there. And then I'll just hit return. Okay, so all three are, in theory, I think, ready to go. I'm going to hit OK and see if this did what it was supposed to do. And you can see that it's relabeled 0 through 9, corresponding, as we had hoped, to the actual right-hand digits options 0 through 9, and then of course we've got actual count versus uniform theory. To get this looking really sharp, I'm going to do a quick right click and format chart area, and maybe choose a fill color that will match the right-hand digits theme, which is this nice looking rose or dark rose color. There we go. That'll match my right digit. And then you can also get the bars to be matching the purple theme here, actual counts. I'd like that to be a light purple, so I'm going to do, I think it's called format data. I don't know if you can see that on your window. I'm going to try that one more time. If you click right on the bars themselves, a right click that is, there it is, Format Data Series, you get an option, all kinds of options to tweak these things. And I'm going to click on Fill and take a look at the light colored purple. Yeah, that looks pretty decent. I think that'll work. Maybe a little bit darker than that. There we go. And then the red ones, I'd like those to be darker purple to match my uniform theory. Sorry I'm taking so much time to address this issue of color, but in my opinion, color does play a key role here. It helps us, the human eye, to distinguish a little better. So I'm going to pick up the dark purple right there. So in a nutshell, the actual count is supposed to be in light purple. I think I got those backwards. Yeah, and I'm going to pause here and fix this. Hang on just a second. Let me try that one more time. I had it right the first time, but I accidentally changed it. So we got light purple for the actual counts, and I should have clicked on the uniform bars. This time we'll get it right. And we'll go Format Data Series, and we'll choose the darker purple. How's that? All right, way better. So I better stop there because I want to kind of talk a little bit about where we're headed next in terms of the left-hand digit. So let me make an end to this part one and get back with you in part two. Thanks for your patience.